This is Dr. Brown, and in this video we're going to talk briefly about numerical integration, which is a numerical technique to calculate the value of definite integrals. You probably will recall when we first looked at approximating the area under a function, we used very often rectangles, and it could be very tedious, of course. Of course, it's a lot less tedious if you use a computer, but we would always get a good bit of error. Well, it turns out that just the technique slightly, instead of using rectangles, using trapezoids. Using a trapezoid, it'll cut down on the error that you make in calculating the integral. And if you look at the first rectangle here, or look at the first trapezoid, the area is going to be y0 plus y1 divided by 2. That's the average value of the two sides of the trapezoid times delta x. And delta x is simply equal to the length of the entire interval, which is b minus a divided by n, which is the number of trapezoids that you're using. So look at this again. We can derive a formula for t, which is termed the area of the trapezoid. I guess they pick capital T to stand for trapezoid. And notice that the area of the first rectangle is going to be delta x times y0 plus y1 all over 2 plus delta x times y1 plus y2 over 2 plus delta x times y2 plus y1 over 2, and keep on going till you get to the last two trapezoid, and the next to the last trapezoid has the height of yn minus 2, so its area would be delta x times y sub n minus 2 plus y sub n minus 1 divided by 2 plus delta x times y sub n minus 1 plus y sub n. And notice that this area now, if we factor delta x over 2 out, that we would have, first of all, y0, but notice we'll get two y1s and two y2s, and keep on going. We'll get two of everything until we get to the last triangle, and the next to the last, the next to the last trapezoid, and the next to the last trapezoid will be 2y sub n minus 2, and the last trapezoid will be just have a y sub n in it. So basically we have a pattern of starting out with y sub 0 plus 2 of each y in the middle all the way till the end, and we just have one y sub n. So this is the equation that you use. And to illustrate, you calculate the integrals wheel. And using the trapezoidal rule with this function with n equal 4 steps to estimate the integral, we will start out by calculating the various values of x and y. Notice that delta x would be 2 minus 0 over 4 equal 1/2. So starting out with our x's and y's, we get 0, 1/2, 1, 3/2, and 2. And the values of y for x equals 0 would be 7. And that would be y0, and y1 would be 1/16 plus 7, which equals 113/16. Plugging in 1, we get 8. Plugging in 3/2, after a little calculation, you'll see you get 193/16. And the last term will be 23. And so the area, which I would call A and they would call T, would be equal to delta x over 2 times y0 plus 2y1 plus 2y2 plus 2y3 and just 1y4, because that's the last one. So plugging in, we get delta x is 1/2 divided by 2 would give you 1/4 times 7 plus 2y1 would be 226/16. 2y2 would be 2 times 8 is 16. 2y3 would be 2 times 193/16. And then finally y4 is 23. And adding all that up, you get 1/4 times 13/48/16. Which is equal to 337/16. Now we will do one more using the trapezoidal rule. Here we have a function 7 over 1 plus x between 0 and 1. Delta x is equal to 1 minus 0 over 4 if we use 4 trapezoids. So we get 1/4, and we'll take and develop our table of x's and y's. We'll have 0, 1/4, 1/2, 3/4, and 1. And then for y0 would be 7. Y1 will be 28/5. Y2 will be 14/3. Y3 will be 4. And finally, y4 will be 7/2. And then the area T would be delta x over 2 y0 plus 2y1 plus 2y2 plus 2y3 plus y4, and plugging in, we get 1/4 divided by 2. y0 is 7. 2y1 is 56/5. 2y2 is 28/3. 2y3 is 8. And y4 is 7/2. And this will be 1/8. And putting in everything with a denominator of 30, we get 210/30 plus 336/30 plus 280/30 plus 240/30 plus 105/30. Adding all that up, we get a 1/8 times 1171 over 30, which turns out to be 1171 over 240. And so that's our last example using the trapezoidal rule. Now, the next technique is using a rule called Simpsons Rule. And it takes 3 points in the interval and fits it with a parabola. And then you calculate the area under the parabola, which you know exactly. And you will pick the width, and after calculating the values of the A, B, and C that give you the best fit to the parabola, arrive at this very simple equation. You still pick delta x equal b minus a over n, and the formula you get for the area, which is called S, I guess for Simpsons Rule, it would be delta x over 3 times y0 plus 4y1 plus 2y2 plus 4y3 plus 2y sub n minus 2 plus 4y sub n minus 1 plus y sub n. So you have this pattern that goes throughout the interval, and you always end up with one of the y values at each end, and 4y1 and 4y sub n minus 1, and then you alternate 2 and 4 in between. Now we're going to illustrate this using Simpsons Rule with n equal 4 to estimate the integral x to the 4th plus 9. The delta x, of course, would be 2 divided by 4 equal 1/2. And now we're going to set up the table of values of x and y. X0, of course, would be 0. and 1/2, 1, 3/2, and 2. And y0 would be 9. Then plugging in 1/2, you get y1 would be 145/16. y2, plugging in 1, you get 10. y3, you get 225/16. And then finally, y4, plugging in x equal 2, you get 25. So then our formula is S equal delta x over 3, y0 plus 4y1 plus 2y2 plus 4y3 plus y4. Now plugging in for delta x divided by 2, we get 1/6. Plugging in y0, we get 36/4 plus 145/4 plus 80/4 plus 225/4 plus 100/4. And adding all this up, we get 1/6 times 586/4 can be reduced to 293/12. Now, the last one just illustrates how a surveyor might measure the length of a piece of land at 100-foot intervals, as shown in the table. So he does it at 100-foot intervals. That means delta x is going to be 100. And we already have the lengths of y0, y1, y2, y3, y4. And so the area of the land is going to be 100/3 times y0 plus 4y1. I usually write down the formula so I can keep up with what everything is.